This example says, write a matrix as the product of elementary matrices. So please be patient. Here, what are we going to do? Remember, when we try to reduce the rows of this matrix, you can form a joining matrix, A, and in this case, I2. Then by applying the Gauss-Jordan elimination, you can convert this into I2 and the inverse of the matrix. So keep that in mind. From recall, we have the following. We have -1, -2, 3, and 8. And then we have 1, 0, 0, and 1 on the right. The very first thing you're going to do, you're going to multiply the very first row by -1. Negative times R1 becomes R1. So in this case, you have 1, 2, -1, and 0, and you're going to copy down whatever you have down here. So what is your elementary matrix here? The elementary matrix is generated from I2 itself, 1, 0, 0. What's the very first elementary matrix? Remember that we are multiplying the very first row by negative sign. So we can multiply the very first row by negative sign. This is going to be your E1. The next step is to multiply the very first row by -3 and add it to the second row. So -3 R1 plus R2 becomes your R2. All right. So in this case, you have -3, you have -6, you have a 3, you have a 0, which is added eventually to 3, 8, 0, and 1. You get a 0, you get a 2, 3, and 1. All right. So this guy becomes 0, 2, 3, and 1. But what is the elementary matrix in this case? Again, all elementary matrices are generated from identity matrix. So you have to have the identity matrix. What are we going to do? We're going to multiply the very first row by -3 and add it to the second row, elementary row operation. So E2 becomes 1, 0, -3, and here you have 1. In the next step, they're going to divide the second row by 2 or multiply R2 by a half, and it generates the new row, which is R2. So as you remember, this is 0, 1, 3 halves, and a half, and the very first row stays the same. So what is the elementary matrix here? From I2, which is 1, 0, 0, 1, you're going to multiply the second row by a half. E3 is 1, 0, 0, and a half. So far you have 3 elementary matrices. You had 3 specific operations. In the next operation, you're going to multiply the second row by -2 and add it to the first row. -2 R2 plus R1 becomes your new R1. So you have a 0, -2, -3, -1, added to 1, 2, -1, and 0, 1, 0, -4, and -1. So this guy is 0, 1, 3 halves, and a half. This guy becomes 1, 0, -4, and -1. What is the elementary matrix? In this case, again, you have I2, which is 1, 0, 0, 1. What are we going to do? We're going to multiply the second row by -2 and add it to the first row. So E4, or the fourth elementary matrix, is 0, 1. And here you have 1, -2. All right. So step by step, we're going to multiply these matrices by A, and it generates identity matrix for us. So E1 times A and E2 times E1, A times E3 times E2 times E1A times E4, it generates I for us. Don't believe me? Take a look. E4 is 1, 0, -2, and 1. E3 is 1, 0, 0, and a half. E2 is 1, -3, 0, 1. E1 is -1, 0, 0, 1, multiplied by matrix A. -1, -2, 3, and 8. So let's multiply these two together. Let's copy down the whole thing. Just want to show you this is the result. 1, 0, -3, 1. And this guy is, here we have 1, and plus 0 becomes 1. Then this guy multiplied by this guy, 2. And this guy multiplied by the very first column, 3. And the second row multiplied by the second column, 8. Now multiply these two. We can copy these down in case we don't want to lose the information. So here the product of these two is 1, the product of these two is 2, the product of these two is 0, -3 plus 3, and here you have -6 plus 8, 2. Now multiply these two, we get 1, -2, 0, 1, and here the product is 1, the product is 2, and here the product is 0, the product is 1, and finally multiplying these two together, the multiplication is 1, then here you have 1 times 2 plus -2, 0, this guy is 0, and here you have 0 times 2 and 1. So as you can see, you have I2. Well, the question says, write A as the product of elementary matrices. I know that E4 times E3 times E2 times E1 times A is I. I'm going to start multiplying from left and get rid of each one of these elementary matrices. Multiply by the inverse of E4. So remember that any matrix multiplied by its inverse result in identity matrix. So E4 inverse times E4 gives me I2. So I have E3 times E2 times E1 times A equals to the inverse of E4. Now from left, again, I'm going to multiply by the inverse of E3. E3 inverse. So it becomes E3 inverse times E3 gives me identity. So I have E2, E1, A, which is equal to, I'm multiplying from left. So it becomes E3 inverse times E4 inverse. Now I'm going to get rid of E2. All of these elementary matrices, they are all invertible. Their determinants is non-zero. Now multiply by the inverse of E2. The inverse of E2 multiplied by E2 gives me an identity matrix. So I have E1A equals to E2 inverse times E3 inverse times E4 inverse. And finally, I need to get rid of E1. So multiply by the inverse of E1. So E1 inverse times E1 generates identity matrix, and A becomes E1 inverse times E2 inverse times E3 inverse times E4 inverse. So we are able to write A as the product of elementary matrices.